All right, let's talk about blockchain. You've definitely heard the word buzzing around, but what is it really? It's this wild technology that people say could change, well, pretty much everything from how we use money to how we even prove who we are. So in the next few minutes, we're going to cut through the hype and break it all down. Simple and clear.
Here's our game plan. First, we're going to look at the fundamental problem that blockchain was created to solve, this idea of trust. Then we'll dive into what a blockchain actually is, how it's built, and the magic that makes it so secure. And finally, we'll check out some real-world uses and see what's on the horizon. Let's get into it.
Okay, so to really get why blockchain is such a big deal, we have to start with the problem it was designed to fix. And that whole problem? It really just boils down to one simple word: trust. I mean, think about it for a sec. Your bank account, the deed to your house, your personal ID. Who's in charge of all that critical data? It's almost always some central middleman, a bank, a government agency, a giant tech company. We basically have to trust them to keep our information safe and accurate.
And right there, that's the weak spot. These systems have one single point of failure. If that bank's server gets hacked, if a government database makes a mistake, or if someone commits fraud, poof, it can all be compromised. Relying on just one authority creates this huge, massive risk.
So if trusting a middleman is the problem, what's the solution? Well, you'd need a system that doesn't require one at all. And that's exactly where blockchain comes in, with a completely revolutionary way of keeping records.
You know, the best way to picture a blockchain is to imagine a kind of special digital notebook. But here's the twist. Instead of one person owning it, everyone in the group has their own identical copy. And here's the most important part. Once a page is filled out and added to the notebook, it can never, ever be changed or torn out. It's this public, shared, permanent record of everything that's happened.
Okay, so now for the more official definition. When you hear distributed ledger, that just means our digital notebook is shared or distributed across a ton of computers. The immutable blocks are just those pages we talked about, the ones that can't be changed. And they're all linked in a chain, creating a perfect timeline. This whole design is what makes the system so transparent and incredibly secure.
So we've got this idea of a shared, unchangeable notebook. But how are those pages or blocks actually written and linked together to form that super secure chain? Let's pop the hood and see how the engine really works.
So each page in our notebook is called a block. And every single one of these blocks holds three key things. First, there's the data itself, like the details of a transaction. Then there's a timestamp, which shows exactly when it was created. And finally, you have the block header, which has some technical info that's about to become really important.
Now, the secret sauce that makes these blocks totally tamper-proof is something called hashing. Just think of a hash as a unique digital fingerprint for all the data inside a block. It's a one-way street, you can't reverse it. And if you change anything, even a single comma, that fingerprint changes completely. It makes any little tweak instantly obvious to everyone.
And this is how we get the chain. It's brilliant, really. First, data gets recorded in a new block. Second, that block is sealed up with its own unique hash, its fingerprint. And now for the crucial part, the next block that gets created has to include the hash of the one that came right before it. This creates this unbreakable cryptographic link. So to change an old block, you'd have to change its hash, and the hash of every single block that came after it, which is a nearly impossible thing to do.
Okay, so this structure is really clever, but how does it create a system that's honest and secure without a single person or company in charge?
Well, this is where decentralization comes into play. Remember that shared notebook? In a blockchain network, there are thousands of computers. We call them nodes, and they all hold their own identical copy of the entire chain. So when a new block is proposed, all the nodes check it over to make sure it's legit and follows the rules. It's like a giant neighborhood watch system for data, which means there's no central server to attack.
But with thousands of computers all looking at the data, how do they all agree on what's true? They do this using something called a consensus mechanism. The two most famous are proof of work, where miners compete to solve a really complex math puzzle to earn the right to add the next block. It's super secure, but uses a ton of energy. And then there's proof of stake, where validators put up their own crypto as collateral, they stake it, for a chance to be chosen. The main takeaway is that both are just different ways of making sure everyone agrees on one single version of the truth.
All right, enough of the theory. This all sounds cool, but how is this technology actually being used out in the real world right now to solve actual problems?
Well, the most obvious fit is finance. Blockchain can make things way more transparent. It can speed up transaction settlements from days down to just minutes, and it can slash costs by cutting out a lot of the traditional banking middlemen.
Now think about everything you buy.
In supply chain management, blockchain lets a company trace a product all the way from where it was made to the store shelf. This is huge for proving something is authentic, improving efficiency, and fighting against fraud and counterfeit goods.
And what about our digital lives? Blockchain offers a path to creating secure, decentralized identities. This completely flips the current model on its head. It puts you in control of your personal information and lets you decide who gets to see it. That could dramatically reduce the risk of those massive data breaches we're always hearing about.
So the potential here is obviously huge, but let's be real, the technology is still young. So let's finish up by looking at the road ahead and some of the major hurdles that still need to be cleared.
There are really three big challenges to tackle. First up is scalability. A lot of blockchains just can't handle the sheer volume of transactions that a system like Visa can. Second, the operational costs can still be pretty high. And third, you've got regulatory hurdles. Governments around the world are still trying to figure out how to even approach this new technology.
But even with those challenges, the vision for the future is incredibly powerful. It's this idea called Web3, a whole new, decentralized internet that's built on top of blockchain. The goal is an internet where we own our own data, where apps are transparent, and where control is put back into the hands of us, the users.
And that really brings us to our final thought. Blockchain is more than just technology. It's a whole new model for how we agree on things and how we establish trust. It lets us put our faith in math and code instead of a central person or institution. So I'll just leave you with this question to chew on. If we can build systems where trust is just built in, what does our future even look like?